Now let's look at a couple of examples. Okay. So in this first example, we're looking at a system where the output is just a delayed form of the input. Okay, so this is a delay system. So what is the impulse response of this system? Okay, what is the impulse response of this system? Let's see if somebody can answer this. 谢冠廷在吗？谢廷冠，对不起。
在。
所以这个系统的 impulse response 会是什么？
这里的 impulse response 应该是应该是 h， 应该是就是 x of t 减 t 0。
所以 x of t 减 t 0是当它的 input 是 x of t 的时候，它的 output 就是 x of t 减 t 0。
对，是它的。
那 impulse response 的话呢
？impulse response 就是 h， impulse response。
所以 impulse response 它的意义就是说，如果我的 input 是一个 impulse 的话，那我的 output 会是什么？这样。所以如果说我的 input 在 x of t 是一个 impulse delta of t 的话，那我的 output 会是什么呢
？delta t 减 t 0。
对，非常好，对，谢谢。Okay. So the impulse response of this system is delta of t minus t naught, right? So this is obtained by substituting delta of t into x of t. Okay. So if the impulse response is this, therefore, this y of t equal to x of t minus t naught is just the convolution between x and delta of t minus t naught. Okay? So this is saying that if you pass a signal x of t through a system with impulse response delta of t minus t naught, it simply delays the system by time t naught. Okay? So this shifts signal by t naught. Okay? So if your system shifts your signal by t naught, then what would be the inverse system? Okay? An inverse system would then be a system that shifts the signal by minus t naught, right? So if the system shifts the signal by t naught, then shifting it back by minus t naught, right, will give you the original signal. Okay? So in this case, the inverse system should have an impulse response that is equal to delta of t plus t1. Okay? And you can check if this is true, right? You can check if this is correct, right? By seeing if the convolution of h1 and h2 indeed gives you a delta function, okay? And this is the convolution between delta t minus t naught and delta of t plus t naught. Okay, sorry, this should be t naught. Okay. And this is equal to delta of t. Now, in this second example here, we have a system where the channel where the impulse response h is equal to a unit step sequence. Okay. So if you plug this into the convolutional sum equation, you can find that the output should be equal to input convolved with this impulse response, which is the sum of xk and u of n minus k. Okay, k from minus infinity to infinity. Now, suppose you're looking at a particular n, right? Suppose, we're looking at a particular n here. Then you can see that this u of n minus k will be equal to 1 when k is less or equal to n, and 0 when k is greater than n, right? When k is less or equal to n, this n minus k is, positive, and therefore it's equal to 1. And if k is greater than n, then n minus k is negative, so the step function gives you the value 0. Okay? So this basically limits the summation for k from minus infinity up to n, right? Because for any k greater than n, this u is 0. So there's no need to sum this up. So you have the summation over this range of xk. Okay? So what is this? Right? This is basically the accumulator that we talked about in chapter 1. Okay. So a system that accumulates the signal from minus infinity up to this current point has a impulse response that is equal to a unit step function. Okay. Now, for an accumulator, what is the inverse system? Okay. So an inverse system to an accumulator is this difference system. So the inverse system is this system where yn is equal to xn minus xn minus 1. Okay? Or in other words, a system with impulse response h1 of n equal to delta n minus delta n minus 1. Okay. And you can check if this is true. So if you take the convolution between h and h1, right? So h is this unit step function, and h1 is delta n minus delta n minus 1. Okay? So by the distributive property, right, we can write this as un delta n, convolution of un delta n, and a convolution between un and delta n minus 1. Okay? And the convolution between any function and delta n, right? Delta n is a identity, the impulse response of an identity system, right? So the convolution of any signal and delta n returns back the same signal, okay? And the convolution between un, any signal, and delta of n minus 1, right, as shown similarly above here, provides a time shift by 1. Okay, so your output would be u of n minus 1. And if you subtract a unit step function and a unit step function shifted by 1, what you have remaining is indeed a delta function. Okay. So this is indeed an identity system. So these two examples we also talked about previously, right, in chapter 1, but now we're expressing it in terms of the unit impulse response. Okay. All right, so let me stop here. So next week, we'll continue to cover properties such as causality, stability, and then, give an example in terms of, systems that can be described by, constant coefficient differential equations. Okay. All right. So if you're not familiar with differential equations, you may want to look ahead into these chapters a little bit. Okay. All right. So do you have any questions? Okay. So if you have no questions, then we can stop here. You're free to leave, and whoever has questions, feel free to stay after. Okay. Thank you.